Hello learners, I am Dr. Neha Parsekar, Assistant Professor in Chemistry at Ganpat Parsekar College of Education. I welcome you all for this Chemistry MCQ Solver course. This module will discuss the problems based on kinetic theory of gases. We will begin with the first question. Question number 1. The kinetic energy of 1 gram mole of gas depends on 4 options are listed: temperature of the gas, nature of the gas, pressure of the gas and volume of the gas. In order to solve this question, one should know the equation for the kinetic energy, that is K is equal to 3 by 2 RT. Here in this equation there are two variables, that is the kinetic energy and temperature, and hence the kinetic energy will depend only on the temperature of the gas. So option number A is the correct answer for this particular question. Moving on to the second question. If the volume of the compressibility factor is less than 1 for a gas, then again 4 options are given. The gas is said to be more compressible, the gas is said to be less compressible, the gas behaves ideally, the gas is easily liquefiable. In this case, the compressibility factor gives you the idea about the degree to which a real gas shows deviation from the ideal gas behavior, which is given by PV upon nRT. Z here represents the compressibility factor. If the Z is equal to 1, then the gas is said to be ideal, whereas if you get a value higher than 1 or lower than 1, then the gas is said to be behaving as real gas. If the compressibility factor is less than 1, the gas will show negative deviation and it will be more compressible than expected. If the compressibility factor is greater than 1, then it will show positive deviation and will be less compressible than expected. From this explanation, the answer is option number A, that is the gas is said to be more compressible as the value of the compressibility factor was less than 1. Question number 3. The temperature at which 3 phases of a substance are in equilibrium is known as Boyle's temperature, option B, triple point temperature, critical temperature, inversion temperature. The answer for this is triple point temperature, because the definition of the triple point says that it is the temperature and pressure at which 3 phases, that is the solid, liquid and gas of a substance, coexist in thermodynamic equilibrium. So the option number B, that is the triple point temperature, is the correct option for this particular question. Question number 4. In the equation PV is equal to nRT, which of the following statement is correct? The first option is P versus V graph is a straight line with positive slope. P versus V graph is a straight line with negative slope. V versus T graph is a straight line with positive slope, and V versus T graph is a straight line with negative slope. If you see the explanation, the plot of pressure versus volume, that is P versus T, for an ideal as well as for a real gas is a curved graph. Whereas if you see the V versus T plot, that is the volume versus temperature plot, it is a straight line plot with a positive slope. Option number C, saying volume versus temperature graph is a straight line with positive slope, is the correct option. Moving to question number 5, the kinetic energy of 1 gram mole of a gas at normal temperature and pressure is, 4 options are given and R value is given for solving the question. So what is given in the question is R value, whatever is provided. Temperature is 273 Kelvin. Formula which will be used to solve the problem is K is equal to 3 by 2 RT. Substitute the values of R and T in this particular equation and you will get the value of K in joules. Correct option for this question is 3.4 into 10 raised to 3 joules. That is option number C. The root mean of oxygen molecules at 27 degrees Celsius is, again there are 4 options which are given. To solve this question, the formula required is mu is equal to root 3 RT upon m. Here the mu represents the root mean square velocity, R is the gas constant, T is the temperature and m is the molecular mass of the gas. We substitute the values, that is 3 is the constant, in place of R, that is the gas constant, the value is substituted in terms of ergs multiplied by the temperature in terms of Kelvin, so it is 300 divided by the molecular mass is 32 because the oxygen is in diatomic form, that is O2, and hence it is 16 plus 16, 32. The final answer after solving you will arrive at 4.8358 multiplied by 10 raised to 4 centimeter per second, that is option number C. Question number 7. Sulfur hexafluoride is a colorless, odorless gas. Calculate the pressure exerted by 1.82 moles of the gas in a steel vessel of volume 5.43 decimeter cube at 69.5 degrees Celsius, assuming ideal gas behavior. 4 options are listed here and in atmospheres. What is given, the data given is N is equal to 1.82 moles, volume which is provided in the problem is 5.43 decimeter cube, temperature is given, that is in degrees 69.5 plus the Kelvin 273, the final temperature we arrive at is 342.5 Kelvin, and pressure is what we want to find out. Ideal gas equation is used, PV is equal to nRT to solve the problem. Terms are rearranged and the values are substituted accordingly. The final value we arrive at is 9.425 atmospheres, which is option number A. Moving on to the 8th question. The value of the critical constants Vc and Pc, that is critical volume and critical pressure for C2H2 ethylene are dash and dash respectively. Van der Waals constants A and B are given. Also the gas constant in atmospheres is provided. 4 options are listed wherein we are supposed to find the value of critical volume and critical pressure. Following formulas are to be used to find out critical volume. Critical volume is given as Vc is equal to 3B. 3B here represents the Van der Waals constant, the value which was already provided in the question. Substitute the values and find the answer for Vc. To calculate Pc, the formula is Pc is equal to A upon 27B square. A and B here is again the Van der Waals constant. It is a direct substitution problem. The final answer we will get is 61.64 atmospheres. Option number A, that is 0.154 liters for Vc, and Pc is 61.64 atmospheres. Question number 9. 1 mole of diethyl ether occupies 15 liters at 227 degrees Celsius. What will be the pressure if the Van der Waals constants for the diethyl ether are A is equal to 17.38 atmospheres liter square per mole square and B is 0.134 liter per mole. R value is again given here, that is 0.82 atmospheres liter per Kelvin per mole. 4 options are provided. To solve this problem, the formula to be used is the real gas equation. The data which is given to us is, we know it is 1 mole of the gas, so N is equal to 1. Volume is 15 liters, R value is provided. Van der Waals constants A and B values are again provided to us. Temperature is 227 given in the problem, plus the Kelvin temperature, that is 273, we arrive at 500 Kelvin. Direct substitution of the values into the equation will give you the value of pressure to be 2.723 atmospheres. The answer, that is option number D, saying 2.723 atmospheres, is the correct option. Thank you.